Hello students and welcome back. So now we are going to talk about one more conditional statement, and that is case statement. So in this video we are going to talk about the case statements, what is the syntax for case statement, how can we use parallel case statements. So case statements are also conditional statements, and as the conditional statements are described, they are used to decide the actions in different situations. But what is the requirement for case statement when we already have if else? Well, in if else, if you have multiple true statements, then every time we have to write if, else if, else if, else if, and else. For that we have case statement. If you have multiple true conditions, we call them true cases, and we define them in a crisp way using case statement. So instead of using if else, else if, and else, case statements are a better choice in such cases. So the syntax of case statement is that we will start with the keyword case and end with the keyword end case. We will write the sensitive ports. That means the input variables on which we have to test our conditions inside the parentheses. The case statement will only evaluate based on the changes on these port values. So if you have 3 input variables and in the sensitivity list you mention only 2 of them, and the third variable value is changing, that will not affect our statements inside the case statement. So here when we talk about the syntax, we say case and list of all sensitive ports, and then we start writing case 1, this is my true condition, what will happen in terms of statements. Case 2, what will happen, and so on. And finally we have a case called default, where we mention if none of the cases are true, then execute these statements, and we end with end case. So we have done one half adder. Let us see how can we implement one half adder using case statement. So I have module, I have input wire A and B, output register S and C out. Here I am explicitly mentioning wire and register because whenever you have the left hand side and you want to store something, storing means register is required. So I am mentioning register here. Then we say always at the rate A or B, that means A or B, any one of them are changing, begin case statement, and inside the curly brackets I have the concatenation of A and B. Curly brackets means concatenation. So we are concatenating A and B. First is A, then is B. So 0 0 means A is 0, B is 0, and 1 0 means A is 1, B is 0. Then we mention 4 cases. 2-bit binary number 0 0. A is 0, B is 0. In that case S is 0, C out is 0. So I am beginning and ending. Everything we are writing in a single line, that is all fine. Okay. Then second case is 0 1. In that case sum will be 1, carry will be 0. Third case is 1 0, where sum is 1, carry is 0, and the last case is 1 1. So this is how we define, and then we say end case and end module. So this is how we write it. Now what we are going to do, we are going to verify the same using Vivado. So we have the same code in Verilog now. One thing again, we must take care that because we are going to use a procedural assignments inside the always block, please remember to mention register for outputs. You should also mention wire 4 inputs, but that is optional as of now. So once we have declared it, we have written all the statements for the cases, and A and B are concatenated using the curly brackets. Let us check that what is going to be the schematic in this case. So the schematic here is using two multiplexer kind of structures which are inbuilt structure in the Vivado. Here you have two inputs which are going as select lines, and then we are selecting these inputs as two possible output. One multiplexer is used to calculate the Cout and one multiplexer is used to calculate the sum. Now we are going to cross check the functionality of the same using the simulation as well. So here we allocate A as a clock 0, 1, 100 nanosecond, and B as a clock 0, 1 with double the time period, that means 200, and we run for adequate number of iterations, and we look at the simulation, and here we have 0, 0, sum is 0, carry is 0, 0, 1, sum 1, carry 0, 1, 0, sum 1, carry 0, and 1, 1, sum is 1, carry is 1. So it is working fine for this. So students, now we know about the conditional statements. In our next video, we are going to talk about loops. Keep learning. Thank you.